every time we cover something here related to space, it's always about, something from the US, maybe China, Japan, Russia, or whatever. And Europe is usually very forgotten. And so, it's about time that we talk about Europe's future in space.
And here we go.
We have liftoff.
Propulsion continues to be nominal.
RCPA chamber pressure looks good.
Doubling up. Roger, roll, planet.
Water towers, fly! Yes! Tango down to nominal.
Flight downside SPD off. Bring in SPD off. Off. It's orange! 145!
Oh my god!
Decollage.
Look at this!
Put that in the big bag,
343 unfolds to go.
Indeed.
We rise together, back to the moon and beyond.
The methane would be igniting in the flare, correct?
Yikes. You dead? Sure. We don't need any more of these.
Hello and welcome to NSF's Europe's Future in Space. We are now on the 12th episode. And of course, you probably know me already here with my very long name, Alejandro Alcantarilla Romero. I'm a writer here at NSF, but I'm also a commentator here as well. And I'm going to be hosting today's show. Now, of course, I'm usually accompanied by somebody else, but this one is going to be a little bit more special. I'm going to be just alone. Unfortunately, DY's had to attend to other commitments. So I'm going to be here also grabbing your questions in chat. So tag at NASASpaceflight at NSF in chat. And I'm going to be bringing your questions here to our guest, Stan Maximin, I think it is, right? And
Yeah.
and so, founder and executive chairman of Latitude. Welcome to the show. It's really interesting to have you here.
Thank you very much, and thank you to all the people at NASA Spaceflight. It's a great honor because I've been watching, even before I had my company, I've been watching your lives, and since then, that's the channel I open up every time there is a great launch coming up. So, hopefully one day you will be covering our maiden flight.
I mean, yeah, we would love to do that. We'll probably talk about a little bit more about that in the show. But also I want to point out something because, here, this is just a green screen. Unfortunately, I'm not,
Not in
I
space,
guess
you're not flying in
thankfully I'm
space.
not in space, I guess. But you don't have a green screen. Like that's actually the factory, right?
Yeah, when I actually came out, my team prepared this, and I was like, I know this is my factory, but it feels like looking at the screen, it looks like a
Yeah.
green screen. And I don't know what can I do to prove, but it's I can walk in the background.
There we go. Yeah. It's an
I can
actual
walk.
factory. There we go with barrel sections. I see the engine as well there.
Yeah,
That's cool.
I can describe some stuff. Yeah, this is well, of course we set it up in a way to show some stuff, but it's one part of the it's not even like a quarter of our factory, but yeah, we have one of our combustion chamber not equipped with this turbo pump because the turbo pump has been turning today on our test zone, and this one has been tested I think 3 weeks ago a few times, and then we have some first sections. Well, when we really come into the back, we have the second stage that is engineering model that's being built, and some other many parts and some stuff that you cannot see, but like the welding station over there on my right behind the camera, there's all the electronic assembly, all the harness assembly and everything. So yeah.
Nice. Yeah, I can see, sometimes again, I have to use the green screen, of course, but you, with an actual factory, a little bit of the factory, as you mentioned, right? There's more. Exactly. So tell us a little bit about Latitude, because I looked your biography and man, you're younger than me. And
Am
it's
I?
a little bit like, yeah, you are. I'm not gonna disclose
you look younger than me.
Yeah, I don't know about that, but yeah. So how to out of the blue now let's make a rocket company. I think you were like 19 years old or something like that, right?
Yeah, around this. Well, I wanted to do this when I was like 15, so it was just at 19 that I took the decision to start.
All right.
But yeah, I
Yeah.
always wanted to do this. Always wanted to build something in the space industry. As many have said in the chat, there's some difficulties in Europe. There has been some difficulties, and you can either do not do anything, or you can, try to be an actor of change yourself. So that's what I'm trying to do, to add something to, first of all, the space industry, and if I can, to my country and my continent. So yeah. So how did it go? Basically, I was passionate about space, rockets, particularly. I'm not an engineer, but I do love engineering. And I actually worked a bit in the US, and I went to see a lot of launches in Cape Canaveral, well, Port Canaveral to be precise. And yeah, and when I came back to France, I knew that was, I started it. That's what I wanted to do. Now it was a complete, let's say it was the first 2 years were quite hard. So the company was, we started the project end of 28, but we incorporated the company in around mid 2019. But it was, we had not a rough patch, but let's say we did not know how to do anything for a while. And we really started when we moved to our current city, which is about an hour and a half from Paris. It's called Reims. It's where the champagne is made. You might know it for this. And that's when we raised the first, our seed round. We hired the first people. We grew the team a bit. But yeah, and then we, let's say, poked around, looked at what we could do, the principle, the market, and stuff like this. It took us a good year and a half, and we really started the development in 2022.
Yeah, and so like, how did you came with a word with a name Latitude? Because I see that it went through multiple different names, right?
Yeah.
And
Well,
yeah,
you
go
know,
ahead.
branding is hard, and we took a while. I don't know if you like it or not, but so the first name, as your colleague from European Spaceflight found out, the first name was Prometheus Space Industries, which was long and bad, and we had to change it for an IP problem, basically, but very early on, so it was not a big deal. So we quickly changed to a venture orbital system, which is still very long. And honestly, well, people thought we were a venture fund, which was funny because we had no money. And yeah, that was, and French people cannot pronounce it. That is like the word venture, very hard. And so yeah, basically we decided we've had enough with the like pure space names and the pure, the orbital, the industries. It sounds cool when there's like 5 companies that do it, but when it's 150, it's a bit less cool. So yeah, we decided to find something that was more like, just global and more simple. And I don't know, we like Latitude. Honestly, it's not a particular story. We just brainstormed for a while, and Latitude came up, and we were like, well, it's French, it's English, and it's simpler. Like, we wanted it to be just like Latitude, nothing else. And what we came to realize is that even French people cannot always know how to spell Latitude correctly. So
Yeah,
we're back at it.
I guess. But yeah, at the risk of making a joke out of this, you mentioned it's a very global name, and I was like, well, latitudes are also, but yeah, like one of the things that
it's global but spacey. I agree.
like one of the things that happened, like we were sort of searching for questions and things like that, and it was like why latitude and not, for example, longitude, right? Because it sounds like the
Sounds bad,
latitudes
longitude,
and
come on.
everything.
It just sounds bad. Longitude sounds bad.
Yeah, right. It's
Latitude,
like
you have the alliteration, right? I'm
there
trying
we
to
go.
justify it. We did not think about that at all.
There we go.
I don't know. It's the principle was we really banned all the like orbital space
Yeah.
industry, aerospace, and everything. We banned this. We just wanted one word. It could have been like, I don't know, like wire. It could have been like blackboard. Honestly, we did not really care. It could have been anything. The key principle, without of course thinking that our brand is as well known as Apple, is that Apple makes computer. You don't need Apple.
Yeah.
Well, they were called Apple Computers Incorporated at the beginning, but now you do not need to know you do not need in their name to be computers to know that they make computers and phone. So what do we need if we get our branding and we execute and we're hopefully are successful? Why do we need to say that we make rockets? People will know it. Like SpaceX could be called something else, and everybody would know SpaceX because there's such a massive cultural phenomenon.
It's one of those things. Like, I'm terrible at names, so I totally understand what you talked about. Going through different names. This one is too long. This doesn't really. Yeah. I really totally get you. So, Latitude, what do you guys do? Like, you've got obviously rockets, engines, and things like that. Can you give me like a little rundown of what you guys do?
Yeah, so we develop, basically we offer launch services to customers who need to put stuff into space. We are a delivery company, space delivery company, but basically people make boxes, and these boxes or packages needs to be delivered to certain spots in orbit. And well, some of them, and a good amount of them, want sometimes to pay premium to be delivered on time and to their doorstep instead of next to the closest city, or not closest, by the way. And yeah, so these boxes are satellites, of course. Well, most of them, and they do Earth observation, any kind of radio frequency, low bandwidth communication, and we can even go into like science in space experiments, in space manufacturing, capsules and stuff. And these people have very particular needs. There are hundreds of them per year, and when you really want to be on time, when you really are a business with financial pressure to get money as quick as possible, to confirm your market as soon as possible and everything, well, sometimes you want to pay the premium to be in space 6 months earlier, or well, sometimes 2 years earlier. And so we decided to basically offer them this service, being the cheapest dedicated rocket in our class in the world, and having a large amount of launch opportunities per year, so that we can basically deploy 4 to 5 constellations per year in a matter of weeks instead of years currently. So that's basically what we do. Launch, and so I say launch services because we sell services, we do not sell rockets. But of course, to be able to send stuff into space, we build a rocket, because unfortunately, it's the only way to go to space for now. Well, not unfortunately, I love rockets, but they're hard. And yeah, so we make a rocket, it's called Zephyr. It's about 20 meters tall, 1.6 meters wide, 2-stage. LOX RP1, and I guess you have a lot of questions, so I'll let you ask more about the rocket. But yeah, and we expect it to launch in the next 18 months for the maiden launch.
Okay, next 18 months, right? We have already a lot of questions asking, like, what are the timelines and where are you launching from it and things like that. So I guess we'll tackle some of these. I mean, we've got here somebody asking, where will they launch Latitude from? I guess Zephyr is your rocket, right? We can see here some of those renders of the launch pad. Where are you launching from?
So we have an agreement. We have multiple agreements. As you have seen, it's not a secret. I was in French Guiana, I think a month and a half ago, something like this, to put the first brick, which was terrible, by the way, not because of the first brick, because we put it upside down, my bad. But I'm not the one who builds the spaceport, so it's a good thing. And yeah, so basically we are going to operate from French Guiana. French Guiana is developing what they call ELM. It's French, so it's a multi-launcher ensemble de lanceurs. I don't even remember. Ensemble de lancement multi-lanceur, something like this. So it's basically, it's a part of the Kourou spaceport, and it's a big empty part. And basically on this, they have 5 spots, and these 5 spots, basically they build the common amenities, some common means, and then you can just get a zone and, cut the trees, get the ground flat, and build your own launch pad. So that's, some people think that it's one launch pad that we share, but not at all. We still build our own launch pad. And yeah, so that's one spot that we can from French Guiana, and we will launch from French Guiana. We also need to be launching from at least one other spaceport in the world, because as we want to achieve 50 launches per year, we will not be able to attain that level of frequency from French Guiana. And so yes, we are basically in the I cannot say it tonight, but let's say in the next few weeks, perhaps early next year, we'll have people will know where we'll launch. We have not yet announced where we'll launch the first maiden flight.
Oh,
yep, we have not yet announced, but it's all going to be announced early next year. But the works are beginning, and we basically are building the first launch pad. And we're building 2 launch pads. We're building a launch pad for our own test zone, where we will basically do full replica of the spaceport, so that we can test the rocket without flying, of course. And we'll build the second one with what we've learned from these tests, so that we can bring it to the spaceport. But we'll be operating from 2 spaceports really early on, like perhaps we'll keep the first one for a year and a half, 2 years, and then we'll add another one, so that we can reach all orbits for customers and reach the required amount of launches per year.
yeah, because so the place that you mentioned at French Guiana, it's like what you said. There's like a complex, but then it's got multiple paths, right? It's sort of, to draw some parallels here, it's like sort of the way SpaceX is acting. It's going at Starbase, where it's like it's one launch site, but it's got multiple paths, right?
Yeah,
is that the way?
Yeah, exactly. Also, like Cape Canaveral, to be honest, you know, you have multiple launching zone. It's almost the same, and you have all the advantages and the issues. But that's the thing for all spaceports, is that once you start having 1, 2, 3, 4, 5 rockets, then you start having not problems, but a calendar management issue that CNES has to manage. And of course, there are some priorities. You know, Ariane 6 is always going to be a priority. Vega is always going to be a priority, and we get that. So it's part of our business. And but we're still happy because it's the most performant launch facility in the world in terms of pure performance, at least when we go into equatorial orbit or mid-incline. And then we'll need another one where perhaps we lose a bit of performance, but we can at least make up for that in terms of number of launches per year. But we still, you know, if we can operate 10 to 15 launches per French Guiana by the end of the decade, we'll be tremendously happy. If we can do more, we will also do more.
Yeah, and I guess having multiple launch pads, right? What you said, it's like you cannot really do all 50, because you mentioned 50 launches a year, right?
Yeah.
So if you want to have the schedules align with everybody else from just one launch site, especially at French Guiana, right? That's probably not ideal. So yeah.
Yeah. So absolutely, and you're right. We'll need multiple launch pads as well, because you know every time you launch, you kind of need to rework. Now we've worked on a very solid, robust launch pad that we call Stage 0. Very robust, concept, but still we'll have some maintenance on it, and we'll perhaps even need another launch pad, one more. We'll see. If we're not forced to, I'll be happy to spare the few millions in investment.
We literally have like a few questions, both about the rocket, but also about the investment, because somebody was asking, like, most 20-year-olds can fund a car. How did you were able, like, to be able to fund a rocket company? Because I mean, it's really complicated in general to be able to get to do this.
That is a question that I'm asking myself every day. Since, the first time we got funding. There are multiple answers, and I'm not gonna answer the same probably in 6 months. But definitely, I have found people as crazy as me, first of all, in the team, but they are as crazy, but they are way more serious in terms of their background and everything. So there are people who know the industry, who know engineering, brilliant people from Europe, from other places around, and that gave confidence to investors that we were not just a paper company. That's the first point. I think second point is ambition. When we built the company, we were the first in France to actually build a private launch company. I think my first investors saw that and said, we're a venture firm. Even if we like fail, it's either we get zero or it's going to be a times 1,000 type of investment, and at least it's good for the country. So I think that's what led it. And then we worked hard, we went through so many problems, issues, challenges that we solved, and we still have problems and challenges, and we still need to solve them. And I think it shows the kind of stuff investors are looking for. And they're as crazy as us. Honestly, our investors are. It would not have been possible without them. And I'm not just talking about money. I'm talking about the courage to take the risks, keep taking the risks, assisting the company, even if it's going bad at some points, because that's the life of a company, and especially a rocket company that burns, well, literally money. And they're incredibly courageous, brave, and we could not do that without them. I'm going to quickly give a shout out, not to all of them because we have many smaller, but basically Crédit Mutuel, BPI, France, also Expansion, Blast Club, UI Investissement, which was the first investor in the company. I have some older people. I'm not sure they want to be quoted, but yeah, and all the investors that have followed us, there's no word. And that's great because we're in a continent that has perhaps forgot how to try to be the best, how to innovate, how to change things. I think we've perhaps stopped for a while on some stuff, not everything, but perhaps we've been a bit too cautious. And it's great to see that some people, and investors especially, are willing to fund the people who have crazy ideas, whether it is from space, nuclear, planes, robots, and stuff, also in Europe.
Yeah.
And that is great.
And it's a good kind of crazy. It's like this is trying to get more of these payloads, and as you said, it's this whole thing of being able to launch them at scale, because it's like 50 launches a year. That's a lot of launches a year for just one company, right? So so you've got the Zephyr rocket. What's sort of the few things that you can run us through? Because it's like the usual questions of like the engine, materials. What do you, and of course maybe reuse as well, if that's even in the cards.
Okay, yeah, I can tell you the brief overview. Do not hesitate to ask me more questions. I'll see if I can answer. And I mean, if I am capable of answering, or if I am allowed to answer. But so rocket, I told you, 2 stages, 7 engines on the first stage, 1 engine on the second stage, vacuum optimized. Of course, they are similar engine. Now, of course, the second stage engine is always a bit optimized and different than the first stage engines. So 2 stages, 20 meters tall, I told it. Basically, the body is in aluminum. This is a full aluminum structure that you can basically also see in the background, but full aluminum. The fairing is not in aluminum. That's the difference. What can I say? It's LOX RP1. Yeah, I forgot to say that. LOX RP1 fuel. The engine is about 38 kilonewtons of thrust at sea level. Sorry, not at sea level, in vacuum. And it's turbopump fed with kind of different turbopump than most people. We actually reused very old Soviet and French technology on this.
Wow.
When I say reuse, we rebuild them because like it's not like they existed anymore. And we use basically an HTP gas generator to spin the turbine that spins the on the single axis the LOX and RP1 pump. So it's a single shaft turbopump, and that spins at 60,000 RPMs and is very powerful. I cannot go into much details on the pressure and stuff like this, unfortunately. But yeah, it delivers a lot of power. Now it has the drawback of being less efficient than pure gas generator, but it's way more efficient than a motopump or a e-pump, which is what we were looking at the first few years of the project. So So yeah, and then also everything on our rocket basically is built for potential evolutions. So when we design the engines, the structures, and everything, it's designed to be changed in the future, whether it is for reliability purposes, economic purposes, or pure performance purposes. Sorry. So for example, the turbopump, we could later put them in, put it back into gas, which will improve the performance by a lot. But at least it allows us to develop a turbopump in less than 2 years instead of taking a lot of time. I think we're one of the few companies to, like, we started the developments without an engine at all. And I mean, let's be honest, we still do not have an engine. Well, I hope that by the end of the year we'll have one, but basically we have not yet done a fully integrated rocket engine test. It's planned in the next few weeks, so fingers crossed. But that is very hard because, you know, basically what you do usually is you start with a rocket engine, or at least a very mature rocket engine, and then you build the rocket up. Unfortunately, we did not have that luxury. So, but yeah, and anyway, so yeah, rocket engine. What else do we have on the electronics? Pretty normal, honestly. We use a lot of COTS, but not only. What can I say? Honestly, it's just yeah, just. I mean, what do you want to ask?
And well,
engine is Inconel 718, and it's fully 3D printed.
All right.
As well as most of the turbopump, which is also 3D printed, which was a big headache, but simplifies massively. Yeah, exactly. So
There we go.
simplifies massively the just the manufacturing of it. Some parts are still, of course, machined, but yeah.
Yeah, because obviously, you know, whenever there's a company here, when we interview them, it's like the usual questions, but also like, you know, you chose aluminum, for example, instead of carbon fiber or steel. Like there are some other companies out there choosing different materials. Like those are trade-offs that I guess you had to go through as you were designing the rocket. And also, like, you know, for people to understand the size, you have some of the sections of that rocket behind you, right?
It's
So
real size,
it's a small sat rocket.
It's a small rocket, yeah. It's
All
really like the like box size. I don't have I do have boxes, but basically I don't know what that is. Well,
like
anyway,
CubeSats and
that's
satellites
basically
like
the
that,
size
right?
of a 12U satellite. This, for example,
All right.
it's a bit small for our customer, comparing to what the customers do, but that's basically almost the size of a satellite. Now, usually the satellites are the size of a washing machine, and up to 2 washing machines. So that's 50 kilograms, 100 and 150 and 200. That's really the most common satellite sizes in terms of their buses. So yeah, that's what we launch. Now to go back onto, actually you're right. We spent a lot of time doing the trade-offs. What we've seen in most projects and companies is in studies or their previous jobs or anything, they have developed technologies. And they are using one bit of the technology to then develop the whole product, the rocket. Which I'm not saying it's bad, but it definitely forces you into that corner. And either you're right, either you're wrong. We decided to basically start with nothing. We just decided to start with, okay, we want to launch 200 kilograms into space at a great price for our customers, a price that we'll know we will sell 50 rockets per year, if not more, and that our customers are ready to pay. We need a rocket that we can manufacture and launch 50 times per year, which also has a big impact on the design itself, because the factory is also the product. And then you look into, okay, what do we do? And we've looked at everything, like at the entrance of our factory, there's a carbon tank. We built one, and yeah, we decided not to go carbon. It's been our choice. We've gone through e-pumps. We've decided not to go with e-pumps. So basically, we've looked at a lot of trade-offs, and yeah, we ended up going aluminum. Aluminum is, let's say, it's good. It's way cheaper, way cheaper than carbon fiber. It's way less performant. So that means we need better engines, basically. But the trade-off that we see is that in terms of like increasing the thrust and performance of your engines. It's gonna be a headache, like in terms of development effort. But once you actually have it, the marginally higher cost let's say per kilonewton or per ISP second of ISP that you get costs way less than going full carbon, for example. It doesn't mean we will not use carbon. We do have carbon on the rocket. We have our COPVs are carbon wrapped, and we'll probably use carbon on the interstage because that's very easy to do and to manufacture and very cheap. But yeah, we decided like aluminum is a good thing. And also something that you have with aluminum is that you can evolve your rocket can evolve and your tools can evolve around the rocket, whereas it's a bit more complex with carbon. Once you have the wrapping machine and everything, and the furnace and everything, it can become a bit more complicated to actually increase the size. Let's look at Falcon 9, right? I mean, it took 25 meters in a matter of 10 years. So you don't want to invest.
Aluminum.
Sorry? Yeah,
It's aluminum. Yeah, exactly.
Most of it, and you don't want to be stuck having spent 100 million on your basically on your production facilities, and like and your engineers being stuck and cannot stopping them from improving the product. So yeah, everything is based on factory, on costs, on capacity to iterate and improve in the future. Like the engine, again, 3D printed, we can improve the design. We have multiple ways to 3D print them, multiple machines. We can either do it in one part, we can do it in multiple parts that then we weld or assemble. So we can change the design, increase a bit the size. What can I say more? Like the turbo pump is a good example. We have other systems that I cannot really go into, but yeah, we've really thought into how to iterate. Now, of course, there are some stuff where we will have bad surprises. You cannot basically have a perfect first rocket. I mean, you can.
Yeah.
If you are ULA or Ariane Group and you've been making rockets for 40 years and you have 10 years to develop your next rocket, then yes, you can have a successful first launch and the rocket's probably going to be good. I mean, in your own perception. But when you don't have the time, you don't have the money, I mean, an excessive amount of money, you just want to fly. And if it sucks, it sucks. That's life. But at least you need to prevent your design to have fatal flaws or technical debt that you will not be able to change in the future. And that's important. And then you need a very high speed iteration capacity, because that's how you go faster to the finished product that will make you cash. And also something that I didn't say, we started by the market. We were always market driven, and then we went down into technical stuff, which is really important. We only make decisions based on our customers and the market. And yeah, we do not make a rocket to make rockets. We make a product that a product that will deliver a service. And our customers, they absolutely don't care what size is the rocket and everything.
Yeah.
If it was a catapult and it was reliable, they would buy it. So yeah, that's...
As long as it gets the thing done, right?
Yeah. I'd rather build a truck that sells, I mean a truck, I mean even a tractor that sells good, than a Ferrari that I cannot make money on.
Yeah, I mean this is one of the things, of course, that I also look at when we're looking at the market and the different companies. Like you see often the ones that are investing on, for example, you were talking about the trade-off with carbon fiber. Like you have to have the tooling, but then like if you want to stretch the rocket and things like that, the tooling sort of limits you because you have to lay the fibers, then the curing and everything, and so you have a set size for your rocket already straight out of the bat, and so it's like. Yeah, that limits you, especially as you mentioned, you probably want to have iterative process there where you can change your rocket down the line. And talking about that, Stan, because I want to ask you the big question that everybody is asking in chat. I mean, I'm seeing Anthony here asking, do Latitude plan on reusing part of the rocket? And planning reusability here as well from magazine. So
no, we do not plan to.
All right.
I can detail it if you want. or if
Sure,
perhaps the
yeah.
answer is enough.
We
But
have time. Yeah.
we've made the calculation. First of all, it's not profitable. Now you can have ecological reasons to do it, which is a point. We actually think our calculation show that it's with that size, it is not economically and economically viable. You could do it. I mean, it's possible. Rocket Lab has shown it's doable.
Mm-hmm. Yeah.
You put a big parachute and splashes into the water, and you recover it, and you can even reuse some parts. So I'm sure it's doable, even on Zephyr, no doubt. But you're gonna spend X amount of money, multiple millions, that you need to have a return on investment on. You will increase the cost per rocket with the maintenance that you hope to decrease at the same time by reusing the components. And then you look at that basically equation of, okay, I'm reusing it, but I have to, but then I'm making less rockets per year. So every rocket is more expensive, but I reuse it. Okay, but how many times can I do it? It's the whole calculus that we made. It's cheaper to produce them new every time. Now, I'm not against trying to reuse it. If we can find a way to make it kind of smart, like, I don't know, or dumb. Actually, no, we usually do dumb things, not smart things, because dumb is cheap. If we can find some dumb way to do it, we'll try. I'm not against it, but it's for the moment not at all in our development plans. Now, maybe I'm wrong. What I've seen is that Rocket Lab has tried. They have stopped it despite having done everything. I think it's not that profitable, if not at all. And I'm not sure it's gonna be interesting on Zephyr. We can try. Well, slap on a parachute in the future. But yeah, it also eats a lot of your performance, to be honest. And it's okay when the rocket has been built for this, but basically we would need a rocket almost 2 times as tall to actually make it reusable in a correct way, like retropropulsive reusability. And for which we think is interesting for the future also, because even if we would like to make it would have been interesting to make it reusable if it helps us learning for the next projects, but parachutes do not really help you learn that much. So we would need to go retropropulsive landing, and that's we do not have the performance.
Yeah, that's one of the things, of course, of small launchers, I guess, where it's like you don't have a lot of margins, right? Because every kilogram counts,
no margins.
Yeah, because I mean parachutes, even a small one, it's still like a few dozen kilograms, right? Just the whole assembly and everything. So yeah, it probably I can see, as you mentioned, right? Like Rocket Lab tried it and it sort of died off. It's no longer a thing. And they've moved on to Neutron. Now Neutron is fully, with the propulsive landing and things like that. So of course the next question, as you can imagine, any big rocket plans in the horizon, maybe?
Yeah.
Sure, right?
Now, to be honest, it's I'll say this. Yes, well, of course we have rocket plans, because our goal is to become a leader in Europe and in the world. So we will not do that with just a small rocket. We expect it to be the best on the market, and we want it to be the best in the market. But it doesn't mean that it will suffice to become the leader in Europe in terms of access to space and to be a contender to be reckoned with in the world. So we'll need new products. It doesn't mean that we want to operate Zephyr for as long as we can. Basically, we want to milk the cow for as long as we can. And we will. And I think it can operate well beyond the 2035. I have no real doubt on this. So yeah, but then we'll need another rocket, and we'll do it when it's the right time, with the right techs and everything. For the moment, we are laser focused on getting Zephyr to the pad. Then we will be laser focused to getting Zephyr profitable. And then we'll get laser focused into, okay, now we have money and we have a stable business.
That's important.
We're profitable. What do? We obviously know what we'll do. We already have the vision and some plans, but I do not want to waste resources until we actually have delivered an orbital flight.
Yeah, that makes sense. I know a lot of people are like, well, if you don't have reuse plans in your architecture, blah blah blah, it's like that's old style. It's like, well, but if it's a small company, you kind of have to start from somewhere, right?
Exactly,
And
yeah.
it's not like you're gonna have all of these. Also, the experience. I imagine that building
Yeah.
a smaller rocket, getting that experience,
Yeah.
really getting into it, and then that sort of
Yeah.
builds up to the bigger rocket
For sure.
whenever that happens.
It is indeed the most important thing. On the reusability part, I can understand. If any big rocket in the future that's not reusable, I think it's going to struggle. Now you really need to go into the economics of reusability. It makes sense in most of the cases. It is not as easy as people think. I do believe in reusability, of course. I think it starts, at least today, it starts making sense when you have a good enough capacity, probably around the 3-4 tons mark, from what we saw, from what we've seen, and my bad, yeah, honestly, from our calculation, you have a sweet spot around the 8 to 10 tons. It really starts to become interesting, and then it's just better and better. And then you want to go into reusing the second stage, and then you go back down in the performance, and you need to still upgrade your launch capacity. But yeah, it's an interesting debate. But I would not like Electron is not reusing their rockets.
Yeah,
I'm not sure they will restart. I mean, Adam Spice and Peter Beck, I think I've told that they might look at it in the future, just not their main focus. They're focusing on Neutron, which I understand. And anyway, nobody can say it's a bad launch company. It's the second most successful launch company in the world right now.
they are.
And they're doing great. So yeah, I think it's at least what we've chosen. And as long as we make money, we're cheaper than anyone else, and we still deliver great service to our customers, I have no doubt that we will prevail.
All right. Yeah. So now to get to that first Zephyr launch, I know that you guys have been testing a lot. So you've got a test site. Where is it located?
It's well, for the people who know France. No, I'm kidding. Even people who know France do not know where that place is. It is in an airport, so it's 45 minutes from our factory, in an airport in the southeast of our place. So it's near Châlons-en-Champagne, and it is a former NATO base that was transformed into a commercial airport. And basically, they still have these kind of zones where they used to put the jets into the bunkers. And we thought it was perfect to build a test zone. So we started working on it 2 years and a half ago on it. 2.5 years ago on it. And we have built 3 operational test stands. We're building 2 more, including the launch pad, the stage 0. We will not launch again, but yeah. And it's
Fingers crossed.
Yeah, we'll fingers crossed. We will not like the Chinese company. Yes.
Yeah.
And that's great because we can basically do anything we want. We can test rocket engines multiple times a day. We have multiple test stands. We do everything ourselves, and we have a lot of partners also, but most of the things are made ourselves. And basically, you can build an engine, ship it out in the morning to the test zone, test it in the afternoon, and get it back to the factory to be controlled in the evening, which is a massive advantage and cuts the iteration time by a lot of time. Yeah, so it's a great advantage. We have an incredible team over there. We have an incredible team in the factory to also do everything. We have an incredible team in the design to actually design stuff that can be tested very quickly. And basically, it has also allowed us to, well, I'll tell you an example. We have probably produced and tested, I don't know, a bit less or around 10 combustion chamber in the thrust chamber in the last 6 months. It would have taken us previously like multiple years to do this. So that really helps. So yeah, that's great. And we even had another successful test this afternoon. And
nice.
My head of comms is not here, so I don't know if I can betray him by telling the news. I will not. But it was a great success on a very, very critical part that is probably the most complex part of the rocket. So we're happy.
Okay, yeah, no secrets. Okay, yeah, we'll keep it there then. So yeah, of course, one of the things that I now wonder, it's like, so you have tested all of these components, the engines, etc. You're building. I mean, we can see there behind you some sections as well, for the rocket. So
Yeah.
what is the path now? You said
One
within
launch.
18 months, right? To that launch. What is that path? What does that look like?
There's still a lot of work.
Mhm.
A lot of work. Our job is far from being easy. It is incredibly hard, and we will have a ton of surprises. Basically, the path now is to qualify the rocket engine for the first stage, and then the second stage. That will still lead us into half of 2026. At the same time, we are going to start testing the second stage by the end of the year and until the beginning of next year, not until, but up to Q1 2026 also. So it's being assembled. We have the actual rocket tanks that are being welded just behind the screen.
Yeah.
And yeah, so we'll do this. The test stand is almost ready for testing and qualifying our second stage. In parallel, we are starting to order the parts for our first stage. And so the engines, the tanks and everything. And yeah, we'll have some work because it's a lot of work into welding and assembly, but we'll also do this. Once all of that is done, oh, sorry, I did not say, but they're going to kill me if I don't speak about them. Of course, all the electronics and software.
Oh, yeah, that's important.
Literally in front of me, so I cannot forget about it. They have done an amazing work. They are well on time, and that is rare to say in our industry. So they have been doing hardware in the loop tests for a while now. They have done multiple equipment tests, qualification, and everything. So yeah, great advance on that too. So yeah, and then we need to basically once the second stage is built, it will give us a lot of information on the first stage also. They're different, but they're the same design in principles. We assembled the first stage, we test it, which is going to be a very critical part because 7 engines to hot fire at once on our launch pad, that's going to be funny. And once it's done, well, we take the rocket out, we separate it again, and we send it to the spaceport, and we do the initial launch. Yes, that's the electrical team doing.
There we go.
And we do the test launch. That can be as soon as Q1 end of 26, Q1 27. And that can be if we burn a rocket on the launch pad, that can take another 6 months. So that's part of the surprises that you have. That's why we test a lot. That's why but we have to take risks. That's part of the job, and we accept the risk. If we learn something, it's a successful test. So yeah.
Yeah. So then it's you put everything together, you put the rocket out there at the test site. You said you will have a replica of all of the launch pad commodities and ground systems and everything, right?
Mm-hmm. Yep.
All right.
Exactly. And we hot fire the engines, the 7 engines.
Will you also do like the second stage as well?
Second stage will not be hot fired, no.
Okay.
So we just all the functional tests on the second stage. And well, let's be very honest, and I'm going to be, what's the probability that our second stage actually separates? And 2, ignites. Why would I lose 3 months on trying to do it?
That was going to be my other question as well. Like, what do you see that first launch? Because, sometimes it's like, I just want to get out of the pad and no pad fallbacks, no burns or anything like that. But then other folks are like, no, I want it to be perfect on the first try. Like it needs to go into orbit. And so it's like, what is sort of the line for success for that first flight, right?
It depends on who you talk to in the company.
I'm sure a lot of people are probably wanting to get it to orbit, but the expectations.
But they're also quite realistic. I mean, I've never lied to anyone. I've never lied to my investors or to anyone. The first flight is not going to go to orbit, very probably. Statistically speaking, there's a very, very low chance. And if it goes to orbit correctly, it means either two things. They're not incompatible to each other. First of all, we spend too much time on the design, which would be sad. And so we spend too much money, and that would not be good. And second point, it means that we were incredibly lucky, and the second flight is going to be a pain in the ass.
Yeah.
So, yeah, no, it's probably not going to go to orbit. Well, let's be honest. Yes, the main objective, which is not a success, but the main objective is to get out of the pad. We do not want to burn a $5 million pad. That's the principle. That would be sad. That's objective number one. Objective number two, to get as much data as we can on the whole rockets. Now we have not yet decided how far that goes. But in my opinion, personally, I would be incredibly glad if we go up to Mach 1 to max Q. That'd be great.
Yeah, it looks like your video might have frozen.
Yeah.
Yeah, but
Alex?
we can. Yeah, I can hear you. I can hear you.
Yeah, but I'm calling my no internet.
Oh, okay.
I'm froze. I mean, I'm just froze.
Okay,
Apparently
we can
they
solve
hear me,
it.
but I'm froze. Okay, my team is gonna look at it.
Okay, we can wait for you to be able to
No,
clear
no
that
worries.
out.
If you can hear me, we can keep
Yeah,
it a bit.
okay. Then we'll do it this way. Yeah.
Great.
I do have more questions if we
please
can
keep going.
Yeah, so of course the other thing was like we saw those renders of the launch pad because you're gonna go through all of the stuff and everything to be able to build the launch pad. I think you're now back.
Yeah, is
Yeah,
yours
there we
too?
go.
Okay, cool, nice, very nice. Welcome back.
We'll show it soon. There we go.
Right.
And so you've got this weird design which looks a lot like
Yeah.
Soyuz.
Yeah,
I've
put
got
it
here a
on
few
the,
questions already. Why does the launch pad look like a Soyuz pad with the 4 big arms here from Canaveral, I think it is.
Yeah, we call
So,
that
yeah.
petals.
Yeah, the pedals like Soyuz.
Yeah, they open. Because it's dumb basically, and we like it. No, I'm kidding. It's we wanted to have the least amount of parts that are actively moving on the pad. And am I frozen again? We have a problem.
Oh,
I think the video is cutting itself. Okay, I'm just gonna.
it's okay. You can do it.
I'm back. I think it just anyway. Don't worry. Yeah. So we decided to have this because it makes the whole operation simpler, and it makes the launch pad. It requires less maintenance. Basically, you would think that actually there's more moving parts, but not really, because the servitude mast is not moving. It stays put. And the 3 petals are automatically, like Soyuz, automatically delivered once the rocket reaches 100% of thrust. So, and then the petals are just mechanically, with counterweights, just drawn back. And yeah, so that's just a really simple design. Now, honestly, the people, when they look at a launch pad, they look at the mechanical parts, which I understand, it's the part that you see. But you have way more to the equation. You have the umbilicals, you have the separation systems, you have the electronic systems. And when we go into this, that's where we are really doing things differently than a lot of people. For example, the whole launch pad is controlled by the rocket, not the other way around. And well, I think only the Japanese do it like this, and it allows for funny stuff to happen. But yeah, and now that's we'll see if we need to improve it, to iterate on it. To be honest, again, the expensive part of a launch pad is not really the steel; it's more of the fluid systems and electronical systems. So we can make it evolve if needed.
Yeah. And I know there's a lot of people or a lot of companies, I should say, where their sort of marketing, if you will, is we're gonna have rapid deployment and our pad is mobile and all of that. Is that also your thing at Latitude, or is like just traditional launch pad style sort of thing?
It depends for the customers. Basically,
Okay.
if it's just pure launch, we need a launch pad where we can easily do a 3-day launch campaign. If we can go down to less, it would be good. But yeah, and also the launch pad is not the only part that limits that is limiting factor into the launch campaign. You have a lot of other systems and required processes that also need to be improved. So if it's really for a normal customer, we can, like, if the customer needs to be deployed into space very rapidly, what he needs is launch rate, not like, is not 24 hours close. I mean, it depends on the type of customer, but what I mean by this is you get reactivity for commercial applications by having reliability and very high launch cadence, high launch rate. For this, you need multiple pads and to be able to produce enough rockets. When it comes into mobile, I see absolutely no benefit to mobile except in a responsive launch type of contract and if you are at war. But I see no benefits into having a mobile launch pad if you're launching just commercial satellites or even defense satellites, but not in a very, if you're not really rushed, let's say. The advantage is for me only responsive launch because it's probably the infrastructures that are going to be bombed first if you go into war. So this can cover almost all of our commercial needs. And when we go into responsive launch, well, there's some other stuff to be done, but you do not, like, the one size fits all is not the best of options. So sometimes you need to, also allow yourself to develop different products for different customers to optimize their experience and answer their needs. So that's what we will do.
Yeah, and of course, we are in our series of Europe's future in space, and as I said at the beginning, normally when we cover stuff around space, it's like always SpaceX in the United States. We've got Rocket Lab from New Zealand. You've got China, Japan, Russia, whatever. But it's like very little of Europe stuff, and yet there's a lot of things going on as we've covered in this series, multiple launch companies, satellite companies, etc., spaceport companies even. We have had 2 of those here as well. And so we have obviously questions here as well. For example, about what do you do that separates yourself from other folks in the European market? Because it's probably one of the big questions, I guess, that a lot of people might be wondering, right? And you mentioned we are going to be the cheapest and things like that. So please, like talk a little bit about that.
Yeah. Again, we're just focusing on what the customers are looking for. We are strong believers that there are a lot of customers that are ready to pay for dedicated services because they're, like, physically speaking, they cannot do business without it. Like, they cannot get into orbits where they want otherwise. And it's just not a matter of, oh, it's nice to have. It's a matter of, if I'm delivering your phone in another country, you're not going to be happy. And you're not going to be able to use your phone. Well, it's the same for satellites. And satellites are slot machines. They make money per day. So every day they're not in orbit, they're not making money. And currently, people think that everyone is launching with SpaceX because SpaceX is the best launch company for small sats. They are turning this around. Everyone is launching with SpaceX because they are the only one offering enough. And by saying enough, I mean there's a 2 years waiting line, basically, on rideshare launches. It works for a good part of the market. They are perhaps 60% of the market. There is 60% of the market that do not need dedicated rides. And that's fine. They're okay. And I'm happy for them. And we are the first to recommend to customers that on some of their flights and satellites, they should use SpaceX. It's easier. But when you want to go to specific places, when you want to do it in a very fast way, which means not deploying your constellation in 4 years, but rather in a few months, well, you don't have a lot of other options than launching with a dedicated rocket. So that's the first part. And that's also where we saw that a 1-ton rocket cannot really give a good service to a 200 kilogram satellites or 200 kilogram batch of satellites. So basically, the economics do not make sense. They're rockets made for bigger or other customers. And when we looked at this, we saw Rocket Lab, great company. They are doing 50 launches per year, and they're selling it at a very high price, which is good. Means that there are a lot of customers that every year are willing to buy at 70% more than what we are selling for. I'm happy to know this. I just know that there are a lot of customers that will be able to launch with us. So that's the main point. So there's Rocket Lab. They're the only one launching, basically. There's Firefly as well, but that's more on the 600, 700 kilograms capacity. And they have not yet launched a lot of commercial payloads since the 2 years they've been operating. And I mean, tell me if I'm wrong, but there's not a lot of other companies actually, except in China, but there are not a lot of Western companies that are operational. And when you look at the companies that are working on a product that is around the 200 kilograms capacity mark, not that many either. There are some, and we are quite confident to beat them. And how do we beat them? And that's then the second part of how do we do stuff. It's basically speed and the right technical approach from what we hope. The right technical approach is not being like going full on a like, oh, I have the best engine in terms of I have the most performant engine in the world, and that's going to be great. Yeah, but your customers do not buy engines. I'm going to have the lightest structures. Cool. Okay. I'm going to be fully reusable, but okay, but your rocket is so small, and like business-wise, it's not an argument. Like you can reuse something, but if it's very expensive from the base, it's going to be very expensive even if you reuse it. So that's not an argument. Like people tend to forget that Falcon 9 became so cheap mainly because of how they built Falcon 9 and manufactured Falcon 9. And then reusability took it down a notch even more. But so we did not do things like this. We really started by like looking at every possibility or most of the possibilities and saying, okay, that doesn't work, that we can do that later. We have a short-term objective, which is to launch Zephyr. Then we have a medium-term objective, which is to make it reliable. First of all, we do not want 10 rockets to crash. That would be bad for business. And then to make it cheap while having the performance. And it's not going to be the first. It's not going to be the second. It's probably going to take 10 rockets to get up to that point, if not more. But at least we know we have a good basis to build on. And we know that we are incredibly fast and we do not spend a lot of money for the amount of engineering that we do, which is the ratio you need to have when it comes to very complex projects and products, systems like a rocket. Because again, you're not going to be good the first time around, so you need to improve it. And the one who improves the faster is going to be the one who's going to be the best in the market. And yeah, and we also started being like basically the product is a rocket, okay, but the product is also the factory and the product is also the launch part. People tend to forget that launch costs a lot, like launch operations. So we spend a lot of time on this, and basically most of your rockets costs come from manufacturing and comes from design. And we also worked in the beginning to get as close as possible to the profitable design that we need.
Yeah, and you were talking, for example, about the number of payloads and the rideshare missions like Transporter, Bandwagon. Like I've got my own spreadsheets and whatever, and it's like I look through the numbers of payloads that they have for this year alone. It's like way over 300.
Yep.
If 10% of those, because you mentioned Rocket Lab still has many customers as well and many rocket launches, etc., etc. They have launched already more than 15 of these. It's like if just 10% of those that go on transporters, bandwagons, and whatnot just move to a dedicated launcher, if there was the capacity for that, it will be like that's 30 plus launches, right? That we will have of small sat.
We estimate that it's let's say 2029 an average. We think that in 2029 there'll be a need for around 120 dedicated launches.
Yeah, because it's going up.
And even if we're wrong by triple that number, like and we're not doing the projection like there's gonna be 40,000 satellites in space in the next 10 years. No. We take just the numbers every year and the average reasonable growth that we've seen, taking into account the constellations that are being developed, the funding of each company. So they're really reasonable numbers. We're not going to say there's going to be 4,000 satellites per year. Nah, it's going to be perhaps 1,500, which is great. Currently, like this year, sorry, we're going to end the year at about 800 small sat. So yeah, without of course counting like some people like to do in their market research, we're not counting, of course, Starlink or Kuiper or anyone. No, not Kuiper. They changed name. Sorry, Leo.
Yeah, now it's Leo. Oh my God, I hate that name. Anyways,
I loved Kuiper. I'm sorry, I'm not gonna get.
Yeah. We're on the same page then.
Thank you. But yeah, so definitely yes, there's the market for it, and when you really look into the numbers, people stop at the people who haven't bought a launch spot have not experienced what it is. When you do, you realize that the launch cost is not the entire decision factor, like at all. You are not just buying the cheapest available, and I'm not even talking about being able to go to the right spot and everything. It goes further than this. For example, how many, you have your spreadsheet, tell me how many rideshare launches, bandwagon and transporter have been this year. We're almost at the end of the year.
Yeah, so there's been 2 bandwagon missions and 3 transporter missions, I think,
so
with a 4th coming up. Yeah.
All right, so 5 per year, 6 per year maximum. Okay, great, which is great. Definitely the market needs this. Otherwise, not enough satellites. And you said 300 satellites for these 5 launches.
Yeah, around 300, a little bit over 300. I just did like a really quick math of like
330. Okay,
exactly.
Well, I'm not going to go into the debate of they're launching almost being empty, but because I think SpaceX doesn't really care when you do 120 launches, you can be not profitable on 6 of them. My point is more on the fact that that's still not a lot of launch opportunities per year. And let's take an example. You have 30 satellites. I'll get a real example. Earth observation companies, 30 satellites, and they have 15 orbital planes, different orbital planes, which means different inclination, hours of launch, well, LTANs, sometimes altitude, and so which means you need to put, and each satellite is 100 kilogram. These are just Earth observation satellites. You need to put basically 200 kilograms per plane, per orbital plane. With SpaceX, that would take you, if you're lucky, multiple bandwagon and multiple rideshare launches, which is not doable, like physically speaking. And even if it was, that would take you multiple years. Now comes into the equation something that we call total cost to orbit, which is, of course, what you pay up front, which for SpaceX, you can go as low as $20-30 million for these satellites. Very cheap, not gonna lie. But then you add the additional costs that are unseen. You have the costs of waiting because you need to deliver your satellites way earlier to SpaceX for integration because they have another 50 or 60 satellites to integrate. You take a lot of time, and once you're deployed, to actually separate from all the other satellites to be able to operate, to have a nice contact with your satellites and not have interferences with the other customers on board. Perhaps you need to move out a bit. And when you go into this, you need multiple weeks or months to actually do so, even if you use an orbital transfer vehicle. You have some other impacts as well, but basically that amounts to a lot of money lost. When you can consider a satellite can make up to $200,000-300,000 per month per satellite, which is the average estimation from our customers, you realize that costs is not the main subject, but time is, because they would rather spend 30 million more or 40 million more on the launch upfront, but then make in less than a year perhaps 20, 30, 40 million more than they would have made with SpaceX. And that's for the people who can have the access to their, or close enough to their orbits, which is not the case for a lot of them. So that's basically the calculation that customers do. And do not forget, satellite companies are data companies, and they are basically investing a lot of capex for then a lot of money coming in. That's why I call satellites slot machines.
Yeah, and I mean, you said data companies and things like that. There's this whole new revolution of like putting data centers in space and things like that. Like that's even going to drive more the number of launches that are going to be needed, and different small satellites up there. And yeah, there's going to be plenty of opportunities, I'm guessing here. So yeah. Now, one of the other questions that I usually ask here, because sort of the typical joke is that here in Europe it's all about bureaucracy. Like we don't create things. Exactly. Like
Yeah.
it's always about, yeah, we just create regulations. We don't really create anything actually. But here is, Latitude being like, we have our rocket. We are trying to get this out the door. So do you think it's harder to do this sort of thing in Europe than say in the United States or other places like China and whatever, right? Like what do you see?
I will take it point by point.
Yeah.
On the regulations, I'm not gonna lie, I have shared some of the memes on Twitter. I agree. We need to strive for a better industry, for a better environment for entrepreneurship, technology, especially deep technologies. Yes, completely agree with this. But if people think that regulations and like paperworks are the biggest struggle in a company, they are in for a big surprise. I mean, don't get me wrong, we've had our funny times with the administration. We've had sometimes multiple laughs on how dumb some laws are. I'm not talking about the people in the administration, like just the laws when you just do stuff like, yeah, just really funny stuff. But honestly, it's not the main problems. It's not the main problems at all. I see that Europe suffers more from a global lack of not ambition, I would say not anymore, but a lack of risk-taking ability. What I've seen from the US, I was in LA like last week or the week before, and I've went a bit of time and I've worked there a small amount of time. What I've seen is it's a completely different culture, and the culture of taking massive risks is not as prevalent in Europe, and you feel that. You feel it in in the entrepreneurship scene. You feel it in the investor scene. I'm not making generalities, but yeah, you feel it in the like governments and the institutions. Yeah, that is really what I think has to evolve and change, and there has been some change, even in France, even in Europe. Is it perfect? No, but I'm not gonna just criticize. We need to do more change, but we need also to be proud of the change we've made in the recent few years. But we are still far away from the US in terms of execution capability, investment capacities, ambition. Yeah, we are still far. I'm not talking about even China, which is also a great contender. My point being that I don't know if it would have been easier to do this in the US because I'm not an American. And and what and America, there's something to take into account is America had in the 90s and then early 2000, and then of course when all the companies, the new space really kicked off, like the phase 3 in the 2010s. Basically, you guys had 30 years of entrepreneurship and risk-taking capacity by engineers, people, and investors from that period. Let's say in the 90s, it was really from what I remember, more successful entrepreneurs that then built their company, like Carmack and many other people, Bigelow and everything. Then in the 2000, also, I'm not gonna lie, of course, Bezos and Musk and Branson, and then it became more VC. But basically, these guys have failed and succeeded 20 years before Europe.
Yeah.
And the real impacts, we have seen it in beginning in 2014, 2015. First a Falcon 9 landing, I think it was the real point, the breaking point. And that's also when the first startups in Europe started. But yes, we are late. What that does is you've had 20 years or 30 years of changing your engineering methods, culture, risk-taking capacity and ability, and also in the VC world and in institutions as well. And this is a long process. It takes time, and we have not yet done that. We are still experiencing that change. We're still having the first generation of engineers that are now in startups and that are now changing things and moving the methods and breaking things and yeah. So that adds not complexity. That's just I mean, if Europe wants to change, we have to go through this. What the US, not anymore, at least not on the aerospace, because you have had great companies that have paved the way before, and you have now still great new companies that are pushing it even further. But yeah, so that's, I think, my analysis of the difference from this. But yes, it's harder in Europe. I have absolutely no doubt that if instead of being born in France, I was born in the US and I was the same person, yes, it would have been a bit easier in the US. I have no doubt about this. But I was born in France. I love my country. I love my continent. I'm proud to be there and do this. And yes, it is perhaps way harder, and it will make the success way better. We hope so. So yeah, and I think I only answered the first part of the question. What was the second?
Well, it's just about the whole thing about being in Europe, where it's like I've seen also more, let's say, more traditional companies complaining about the fact that, well, in the US, SpaceX was sort of babysit by NASA. They had a lot of billions of dollars,
Yeah.
et cetera, right? And ULA and all of these other companies as well, they got billions. And meanwhile, the European Space Agency is like, here, a couple of millions, right? Like, they complain about that. But then as we have had other small sat launch companies, they've been like actually very thankful about the cooperation and funding and things like that. Like, what's your take on that? On the support from institutions and whatnot, I mean.
Definitely, the project wouldn't be here with the support that we've seen from France, majority, and Europe as well, especially the EU Commission. So yes, this is part of the development. We're building in a space that is very close to institutional. And of course, that means that your funding will be mixed between institutional and private funding, and that your contracts are going to be mixed between commercial and institutional contracts. So what we've seen is a bit of change. For example, we have a contract with CNES for our first launch and for our additional potential launches. This kind of contract that CNES has done would have been impossible 4 years ago. They completely changed their the way they work, and that is a great shift. now we need to go even further. We need to, first of all, prove that we can deliver when they trust us, and they need to think that now it is business as usual. But definitely, the institution have been of a great support. Without, I think I can, and I will not, but I think I can name on the top of my head some people that are entirely responsible for, I think, reviving is not the term, because the space industry in France and Europe are still very, very important, but for pushing the new space industry in Europe and making it and giving it all the chances that we need it. Now, at some point, also, you need to be independent, and like the state cannot provide you with all the money in the world, and you need to make it on your own. And there's the financial market that decide who wins or not. Sometimes they're right, sometimes they're wrong. There's then the commercial market that is the last, let's say, real contender. Most of the time, the companies die before they even had a chance to fight in the market. That's because, space is hard, as we say. But definitely institutions were absolutely key. I would not be standing here in front of you without them. But at the same time, there's still a lot of work to be done in Europe to evolve our way of contracting, doing things, and seeing competition. I mean, the word competition is almost taboo. I don't know if the word exists in English. I think so. You use it as well. But it's almost like a gross word, a bad word. At least it was for a long time in the space industry in Europe. The word competition. Like, I think I'm not the worst capitalist in the world, even though I was called an astro-capitalist, so perhaps I am. But I think I'm not the baddest guy in the world by saying that competition brings out the best out of us. And we want to work harder than our competitor. We want to be better than our competitor. We want to sign more contracts to make a better product than our competitor, and that's good. But for a long time in Europe, it was seen as a bad, basically, or not optimized way of doing things. And I think that slowed us down for a while. And I think that the new space industry is bringing that back. A lot of new companies competing with each other. And I think the states should not be choosing. They should just, they should be choosing at one point, but they should watch them. And again, companies should be able to fund themselves. The state can help, but should not be the main funding source. But that's hard to do, because you need to do trial and errors on this, which is very new for Europe, at least on the space industry. I'd say it's a long process, and people can be, and I'm the first one to be sometimes just how to say it, fed up by how long the process takes. But that's part of the process, and in the long run, the whole industry will benefit from it. Now, I am an optimist, even though I am sometimes cynical, but I am an optimist. And so what I see is that we have no other choice anyway. So either the space industry in Europe dies, either we change. And I think most of the people decided that we change. Some companies perhaps haven't yet seen that they should change. And you know what? If they die, that's part of capitalism. You cannot have the good part of capitalism without the bad parts.
Competition, as we were saying, right? Somebody was asking even about that, about the optimism, like what's a good way to keep optimism going? This one is more for the interview for you.
That is such a good question.
Yeah.
And if I had the answer, I would be a way better boss, which I hope I'm striving to be, or to become. It is super hard to keep optimism for myself, for the company, because you'd spend years and years developing stuff on your screen, so you don't really appreciate the small successes. Then you build the parts, you have problems, and you're like, oh, damn, I've spent 2 years working on it, and my supplier is late, or blah, 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 or I just fucked up on the plan. And it's bad. And then you go and you test it, and it doesn't work. We have failed so many tests it doesn't work. And then it's hard. Honestly, it's super hard. And it's hard for me, but I know it's even harder for my teams because they have poured their hearts, tears, sweat, and toil, as said Churchill, onto the project. And so how do you keep optimism? I've not yet found the right way to do it, because what we are basically is we are a bit of how do we say? We're a bit of junkies. We are spending years and years on one thing for only to be happy for 35 seconds, for an engine to be working, or only for 7 minutes for a rocket to be launched. And that's, so you have very high highs and a progressively lower descent on the developments, and that's alternating between this. And the question is, how do you keep the lows relatively flat? I think you have to really appreciate the small things. We do not enough appreciate the small things, and even like even engineers and our people do not realize that sometimes you have small successes that are so important, and it's not about the end success, it's about the journey that gets you there, and it's about the compound effect of small successes that you celebrate every time, and that is a big managerial challenge. That is a big cultural challenge. We don't do it enough. We want to do it more. We have to do it more, but it's I don't have the perfect answer to this. It's one of the most complex part, definitely.
It's one of those. It's one of those tricky questions from our viewers, of course.
But it's super interesting one.
It is.
If you have a recommendation to the viewer, tell me. I'm glad to implement them.
It is. I mean, and being the boss, of course, that is a very appropriate question. I do have another appropriate question as well, and that is internships. Somebody was asking, as space fan, saying, "I'd love for information if they have internships for students." And we usually do this where it's like, do you have any openings and things like that?
You can go to Latitude. That's 1T. That's 1T every time. Latitude.
There we go.
Oh well, you are perfect. Latitude.eu/jobs, I think. And yeah, or you just go to latitude.eu and you have you can go to the careers part, and you have all the jobs opening for internships. When you have dedicated internships, you can find them here. If you don't find your specialty, you can still send us an application through the website, and we will look at it and we will tell you if it's doable or not. So yeah, that's the best.
Yeah, we can see a lot of the internships there. So hopefully, I've already seen a few people from speaking French in chat, but I'm guessing this is open, obviously, to not just France, right?
Yeah, it's open to everyone. Like we have that's too bad I cannot show you, but we have the wall of flags, the other side of the factory, and yeah, I think there's like oh yeah, I cannot count. That's too many. I think we have like 16 or 17 flags. So yeah, that's a lot of flags. So you're welcome from anywhere in the world. Except if you are a spy, in which we will find you.
Yeah, no spies.
no spies, please come on, be nice. No, but yeah, honestly, open to everyone and anyone. We are not only recruiting from the space sector. We don't really care if you're a smart engineer, ambitious person. If you have the right attitude, we will get you on board, and we will love to have you.
Yeah, well, we will love to have you as well again once you get closer to the launch pad. Maybe after the first launch, we can obviously try and arrange that. Maybe also live stream the launch. I don't know. We'll see all that. We'll see. But anyways, thanks for coming to the show, Stan, because it's
so much.
A pleasure. And of course, yeah, go ahead.
No, sorry. I was going to say it was great. Thank you very much. I really appreciate it. Doing this with you all, and it's an honor again to be here.
Yeah. All right. And of course, as always, we like to thank, of course, our launch director and flight engineer members, because they help make these shows. Of course, every level of membership, but these are the top tiers of membership in our YouTube. Like, there's so many names there, I cannot even go through any of those, so that's why we show them here, top tiers of support. So thank you for that, as always. We got a few support as well here, like people becoming Red Team memberships and things like that. Like we had a bunch of things going on here. Of course, the main thing was this interview. So thanks for coming to the show, Stan. And you know, we'll try to get you back again once you get
Gladly, sir.
that rocket out there.
Great. Thanks a lot.
And as always, that's gonna be out for this show. As we're gonna try and have a few more companies here. Maybe once we get into the next year, because it's already close to Christmas. I'm going in vacation for the next 3 weeks, so you're not gonna see me here at NSF for a while. But we'll be back with another one, hopefully in a few months, with another Europe's Future in Space. Until then, see you and thanks for watching.
And here we go. We have liftoff.
Propulsion continues to be normal.
R68 chamber pressure looks good.
Following up. Roger, planet.
Water towers, fly! Yes! Tango down to nominal.
Fighting downside speed off. Say again, SPD off. It's orange!
Oh my god! Oh my god!
Décollage.
Look at this!
Put that in the big bag,
343 unfolds to go.
Indeed.
We rise together back to the moon and beyond.
This methane will be igniting in the flare, correct?
Yikes. You good? Sure. We don't need any more of these.